Hello, welcome to Team 5's preliminary design review. My name is Marian Sua and I will be introducing our project. Our team is going to be working on Project 47, the Space Flight Traveler. A little background on this project. ASU's School of Earth and Space Exploration is preparing to build a lunar probe called LunaMap. This probe will be launched into orbit about 7 miles from the moon's surface, and its mission will be to search for hydrogen deposits at the moon's south pole near the Shackleton crater. The goal for our project is to help enhance quality assurance for the LunaMap team by designing and implementing a web application that will allow them to create assembly procedures on the fly and track, access, and store manufacturing travelers from the convenience of a touchscreen tablet. These manufacturing travelers will document every step of the probe development, including but not limited to critical tests and checks, serial numbers and images for components, bolt torque, and functional test results. The app will allow engineers to sign off on critical steps or tests. The application will also allow for team members to generate engineering change requests and engineering change orders if or when an issue arises. And once the travelers are complete and signed off on, the application will allow for export of the traveler to the team's Google Drive or storage. The team designing and building the LunaMap is scheduled to begin work on the probe in January of 2018. So our goal is to get a minimally functional application up and running by December, and then to spend the spring semester working out bugs and adding extra functionality. Now I will pass it along to Josh, who will be discussing our project design and architecture.
Thanks, Mary. Hello, my name is Josh Lyons, and I will be discussing the design and architecture of the Spaceflight Traveler project. Let's begin with the design. For the design, we wanted responsive and dynamic web pages that would allow the user to work on a tablet or on a desktop depending on where they were at the time. To accomplish this design goal, we decided to use React.js as our web front end. Not only will this allow for dynamic web pages that change depending on the platform, but will allow us to build our components that can be reused in different parts of the web application. This will save us time and effort. Next, let's talk about the architecture. The Spaceflight Traveler project will follow the model view controller pattern, which allows us to separate components, which will aid in clean code and easier development. The main way the MVC works is the view, or front end, will request data from the controller, or the back end. The controller will then ask the model for the actual data and then return that data to the view. We will also be using Java for our backend with a REST API and a NoSQL database to store all of our data. The NoSQL database will allow for quick iterations as the tables do not need to be defined beforehand and can change on the fly as we add more fields and data. Next up is John with the implementation strategy.
Hello everyone, this is John, and I'll be discussing our implementation strategy. Here on the left side, you'll notice our high-level work breakdown structure. Let's start with the web-based front end, which will be handled by Mary and Andrew with some help from Matthew as well, who will be floating between the front and the back end. With the front end, obviously we'll need to design the UI, as well as implementing several items requested by our sponsor, including tracking capabilities of different users and parts, creating engineering change orders and requests, record keeping of the traveler, as well as being able to export the traveler to a PDF with pictures, which will help with them referring to this information easily down the road. I'll be handling most of the document-based database, which we will be using Amazon DynamoDB. We'll need to set up the database, design the main documents needed, and then connect it to the backend. Josh will be taking the lead with the RESTful API, which will connect with both the front and the backend database. We'll be designing the architecture and determining functions that will be needed to store and retrieve. Finally, we will be delivering the documentation. We'll be determining the capabilities of the system and then writing the installation and user guides for our clients. Now let's talk about our timeline moving forward. We've been given an aggressive timeline here in the fall semester, as basic functionality is needed by January. We've set some milestones for the fall, including completing the design and wireframes, building the database, a functional web app on the front end, and integration of the front and back end. As we move ahead to the spring, We'll be adding several pieces of functionality, including having the ECRs automatically being sent to the desired user, having the travelers being linked with each other with added tracking, as well as photo capability I discussed before. Now I'll pass it over to Andrew, who will talk more about our process.
My name's Andrew. I'll be going over the process for our project. We've decided to go with an Agile Scrum process, which we all learned from Software Engineering 316. We've broken down our Agile Scrum process into 2-week sprints with demos to the client after these sprints. We've done one demo to the client so far, just showing our mockups for our user interface, which is the main thing that they'll be interacting with. And it went really well. We got great feedback from him. And we also adjusted some of our requirements based on that feedback that we didn't really fully understand. So the process so far is paying dividends. Our team member roles are listed here on the slide. I'm not going to read them out. As far as project management tools go, we'll be using Confluence, Jira, and Bitbucket, which are all part of the Atlassian stack. Confluence is a documentation tool. It lets us write down our requirements, use templates to take care of meeting notes. It's where we built our project plan. And it links to Jira, so you can create issues directly from your documents. Jira is our sprint. It's the sprint planning software, essentially. You track all your bugs, your issues, your backlog items. You start and stop sprints there, close out functionality, and all that kind of stuff. Bitbucket is a web-based implementation of the Git distributed source control system. It's a lot like GitHub, but it has tighter integration with Jira and Confluence, so you can actually close issues in Jira with a commit, as long as you tag it with the issue number. We plan to keep our master branch clean, which means one person, the Git master, will be responsible for merging major release candidates into that master branch. That is it, and I'll turn it over to Matthew.
My name is Matthew Cleary, and I will be discussing the risk management plan for our project. We began as a group by identifying 11 potential risks that we might encounter during development. These primarily fell into 4 major categories. There were problems with team member or sponsor availability, problems communicating within the team or with our sponsor, problems with handling the distributed nature of our team and the work, and problems with the tooling and technologies employed in the project. For each risk, we discussed and assigned a probability of either low, medium, or high, and a severity if the risk was not addressed, ranging from minor to moderate to significant, and finally to severe. We used these ratings to prioritize our risks. We then created a set of activities to mitigate each of these risks we identified. Some of these activities were only needed at the start, such as training on new technologies or clarifying tiers of requirements, while others are part of a consistent and ongoing effort throughout our project. These ongoing mitigation activities primarily revolved around 2 areas of concern. The first is scheduling, ensuring that our personal, work, and competing school activities are shared and accounted for in our project schedule, and also making sure we are consistently reviewing and adjusting that schedule. The remaining activities largely focused on maintaining effective communications within the group, as well as with our instructor, sponsor, and any absent team members should that situation arise. To conclude, with this plan in place, along with our design and implementation strategies, and the process we have established, we are confident that we can successfully deliver a product that will meet our sponsors' needs. We thank you for your time.